Computation of the Rfactor. The Rfactor is computed for time periods greater than 20 years, so that wet or dry rainfall periods will be incorporated, eliminating any bias. It is set equal to the average of the sum of the erosivity values for every year's rainfalls. The coefficient is defined as the product of the kinetic energy of an erosive rainfall event by the maximum intensity of a 30-minute duration rainfall, during the rainfall event. Where n is the number of years in the record, mj the number of erosive events during year j, and e at 30, mjm ha-1 hour -1, the rainfall erosivity for event k. The erosivity of a particular event is where is the kinetic energy per unit of rainfall, mj ha-1 mm -1, vr is the rainfall depth, for the time interval r of the hyetograph, which has been divided into r equals 1, 2, m subintervals, and I30 is the maximum rainfall intensity for a 30-minute duration. For the computation of numerous empirical relations, involving rain intensity have been proposed. Thus, in USL, the empirical relation of Whitmire and Smith was used. The three different kinetic energy equations used in USL and its revisions. The points are actual data, showing the relation between intensity and the kinetic energy of the rainfall, converted to SI units and coming from Hahn et al. With the upper limit of 0.283 megajoules Ha-1 mm -1 if I greater than 76 mH-1, where I is rainfall intensity. Later, in Roll, the exponential relation of Brown and Foster was used. Upon comparison of the equations used in USL and Roll, McGregor and Muchler found out that for rain intensities up to 35 mm per hour, 5, yields results by 12% less than those of 4, and they proposed a modification in the value 0.05 that controls the rate of change of with I. Thus, in Roll, the following relation has been adopted. 5, was developed for an application concerning reordered rainfall intensity data and not natural rainfall data. The systematic underestimation of has been shown in many other studies, so, 5, should not be used for calculations. The rules that apply in order to single out the storms causing erosion and to divide rainfalls of large duration in Roll 2 are: a rainfall event is divided into two parts, if its cumulative depth for duration of 6 hours at a certain location is less than 1.27 mm. A rainfall is considered erosive if it has a cumulative value greater than 12.7 mm. All rainfalls with extreme EI30 values and a return period greater than 50 years are deleted. A rainfall event is divided into two parts, if its cumulative depth for duration of 6 hours at a certain location is less than 1.27 mm. A rainfall is considered erosive if it has a cumulative value greater than 12.7 mm. All rainfalls with extreme EI30 values and a return period greater than 50 years are deleted. The current revised version of USL, Roll 2, introduced the erosivity density, ED, as a measure of rainfall erosivity per unit rainfall to develop erosivity values for the USA, because ED requires shorter record lengths, as 10 years leads to acceptable results, allows more missing data than R, and is independent of the elevation. Where mj is the number of storms during a time period j, EI30k the erosivity of storm k, and pj the total precipitation height for the period j, usually monthly or annual. Vondas et al. Using a numerical scheme with data from Greece showed that ED is more robust against the presence of missing precipitation values, as reflected in the following results. Using only 5% of the data, annual R values are underestimated on average by 85%, when the average estimation error of ED values is 50%. In the presence of 50% of the data, R values are underestimated by 49%, while at the same time, the estimation error of ED is 20%. Using only 5% of the data, annual R values are underestimated on average by 85%, when the average estimation error of ED values is 50%. In the presence of 50% of the data, R values are underestimated by 49%, while at the same time, the estimation error of ED is 20%. The use of ED permits the utilization of data consisting of daily rainfall values that are more abundant in comparison to data from pluviographs. The details of the method, which was employed in the USA in combination with Kriging, may be found in the Roll 2 science documentation.